Peter Ledbrook, and I'm a member of the core Grails team and co-author of the book Grails in Action with Glenn Smith. In this talk, in this webinar, I'm going to be discussing how you can improve the performance of your Grails applications and hence how improve your users' experience. Although there is a Grails focus, a lot of the content is applicable in general to web applications. And even if you don't know Grails yourself, you should get a good feel for how Grails can help you and what things are available, what techniques are available to you. It always seems that everybody wants to be another Facebook. Everybody, before they start their application, before the startup is off the ground, they're kind of making decisions based on the fact that they're going to get millions of people. And there are 2 points to really bear in mind with this. First, even Facebook started with only a few users, as you can see from this graph. Admittedly, even back in December 2004, there were 1 million users, and I think many of us would be happy with that number. But the key point is that you don't typically start off with those numbers, and you have the time to fix any particular performance issues as you go along, and we'll be looking at how to do that. The other point is that scaling, going to that number of concurrent users, throws up a lot more issues than which framework you choose. So the key takeaway from this talk is we want to avoid this concept of premature optimization. And that includes making initial decisions about what frameworks you use, what tools, libraries, how you architect your application. It's pretty clear in the evidence that we have that we're quite bad at assuming what works, where the problems lie. And so the key is to profile before you optimize. I know it's been said a lot, but it's very easy to get into the mindset of, I know what the problem is with this. So always bear in mind, keep it in the back of your head whenever you're making decisions about performance or even looking into performance problems. Make sure you profile first. With a typical web application, with a typical Grails application, you have to wonder, where can you get performance issues? This is a little diagram showing you that you've got the database layer typically, where you're storing your persistent information. That's one area where retrieving the data can be quite slow, retrieving and storing. You also have typically a business logic layer above that, which is involved with retrieving the data and processing it and doing other business-oriented work. Then you hit the network, and that's you've got other types of performance issues there. You've got latency, you've also got bandwidth issues. How long does it take to transmit megabytes of data? And less well known, but you also have issues with the user experience in terms of responsiveness on the UI. You have in a Grails application both the HTML generation on the server side and often the JavaScript and resource loading from the browser itself. As I said, before we look at how we improve the performance, we need to know how to profile a Grails application. On the server side, there are various tools available to us. The first one is Spring Insight, and I'm going to be looking at that in a quick demo. That comes as a part of TC Server Developer Edition. It's a free download. There are various ways to use it. I'm going to demonstrate SpringSource tool suites, but you can also download TC Server and use it in that way. There's also a very cheap and cheerful profiler plugin, which allows you to monitor how long service methods take, how long requests take, how long it takes to render views. So that gives you quite a bit of useful information about your page rendering. It doesn't go down to the database level, but it is cheap and cheerful and very easy to install and use. Further down at the database level, you've got Hibernate logging, which basically allows you to see what queries are being made in the log files, and if you go to the trace level, you can see what parameters are being passed as well. It does mean processing log files, but you do have this out of the box, and the user guide gives more information about that. There is a P6 Spy plugin, although I think that's getting a little old now, and that plugs in its own JDBC driver and generates JDBC logging from there. There's also the option of looking at Hibernate statistics and getting more detailed information about what's going on, particularly when it comes to the cache, the second level cache, as well as the JDBC queries, and I'll talk about caching later. Of these, I definitely recommend you look at Spring Insight and this App Info plugin. That provides more features than just Hibernate statistics. It gives you a view inside your Grails applications and provides a lot of useful information beyond the performance, the Hibernate statistics. On the user interface side, these are basically tools that fit inside your browser. Chrome, Safari, and Internet Explorer come with their own developer tools. They're generally very easily accessible. They are great for debugging your JavaScript, your CSS, and your HTML, all of those things, but they also provide feedback on how long it's taking to load resources, what's happening on the network, and so on. For Firefox, you have the Firebug add-on, which is pretty well known, and for Opera, you have Dragonfly. Beyond that, Google Speed Tracer is an extension of Chrome, and that gives you even more information about, particularly about JavaScript and how that's loading and how that's executing, and is useful for determining where you can improve your JavaScript performance. I won't be talking about that further in the rest of the talk, but it's something that you can look into yourself. It also comes with Spring Insight integration. For Firefox, there's a plugin called YSlow. It depends on Firebug. This will give you heuristics about how to load resources and various other things. We'll see it in operation later, but it basically gives you a rating, a grading system. So it will say for this particular heuristic, this category, you get an A, B, C, or D. So you're looking to go from S up back to A's. So as I said, look at that a bit later in a demo. And finally, PageSpeed is a similar tool from Google. It's available for Chrome as well as Firefox. Okay, so in this quick demo, I'm going to demonstrate how you use Spring Insight via SpringSource tool suite. So first thing is you have a TC server in your Servers tab. Double click on that. There's an Insight tab down at the bottom. You need to check this Enable Gathering of Metrics box and save before you start the server. Now you're ready to collect statistics. We just drag our Grails application to the server down in the left-hand column and wait for that to publish. That takes a little while, particularly as it has to build a WAR file first. Once that's published, we just start the server and wait for that to come up. So our server's now running with the application. So if I now go to my browser and go to the main page, remember the first request is always going to be a little bit slow because it's compiling things in the back end. Log in, have a look at the timeline, add a new post. As you can tell, this is a little bit of a Twitter clone. We submit that, and now we've got a couple of requests in there. It's time to see what Insight can tell us. So we go to /Insight, which is where the Insight web application exists, and there are 3 tabs there. I'm going to come back to Browse Resources. The one I want to look at the moment is Recent Activity. This will show you bars for all of the requests for a given time slot every 5-10 seconds. And as you can see, as we hover over each of the bars, we can see which requests are coming through. So if we look at this last one, it's add post Ajax URL. That's when I submitted my post. And if we look here, you can see the full route that the request took through the various filters, down through the Spring MVC dispatcher servlet into our post controller, the add post Ajax action, which is delegating to a post service. And we can have a look at the details of that and see that it's a transactional service, and those are the details. And then you can dig down all the way down to the JDBC query level, and you get the full details of what the query details are and what the parameters passed were. So you get both bits of information at your fingertips. And as you can see, there's also a column of times, which are the milliseconds, how long each thing takes, which is the key information that you're after. I'm now going to demonstrate running a JMeter recipe, and this will just send a whole bunch of requests, 200 requests in total, so that I can demonstrate another aspect of Spring Insight. So at the moment, I've shown you individual requests and how you can drill down, but you can also look at requests as in their bulk and see what sort of statistics that you're getting out of it. So when we look at browse resources, we can see we've got all these URLs. I was hitting with JMeter the post controller timeline action. So if I click on that, I can see I get a nice graph of throughput trend, error rate, response time trend, and a bar chart, which as I hover over each of the bars, I get to see how many invocations there were and how long they took to come back to the browser. As you can see, it says I had one frustrated, i.e. that was took a really long time, 10 that were, on the border but okay, and the rest were, perfectly fine. So you can see how your application is performing under load, as well as drilling down and seeing what individual methods and queries are causing specific issues. So that's Spring Insight. Let's assume that you've profiled and now you know where the various issues are. So this is where we do the tuning. Let's imagine that we've got a database problem. What sort of issues typically crop up in a Grails application? Well, they're similar problems as you would get with a standard Spring MVC and Hibernate application, or anything that uses a database at the back end. You may find that you're generating a lot more queries than you think. So one of the key actions would be reduce the number of queries. With Hibernate, this is a particular problem because you have lousy loading of collections. So you often find that as you iterate over a collection, you find that you're triggering an extra query for every iteration. So if you're using Spring Insight, you will pick up on that very, very quickly. Or even if you're using the Hibernate logging and statistics, you will see that you're getting all these queries. In that particular case, you want to use the appropriate fetch mode, and in the next slide I'll show you how to do that with Grails. Also be careful you're not fetching too much data, although it's better to fetch too much data in very few queries than too little data and too many queries. So make sure you only get the data you need. Beyond that, you may find that queries are slow themselves. That could be because you're querying on a particular column, say a username column for a user table, and you're doing that query very, very frequently. So one query may not take very long to execute, but you may be executing it a lot. And in that particular case, you might want to add an index to the username column. And in the next slide, I'll show you how you can do that with Grails as well. You may also find that your domain model just isn't suitable for high performance, that there are structural problems that mean your queries, when you need the data you need, when you get the data you need, it's taking too long. It's really good idea to find out about such problems early on before you go to production. It's very difficult to change your model, change your database once you've gone to production. So always make sure you do some of the load testing and profiling before you go to that stage. There is also a particular issue with Hibernate and Gorm, which is that if you're using collections, it's not commonly known, but if you're using collections that are sets or lists, they're always loaded whenever you want to add an item to that collection. And if you've got a very large collection, that means you could be loading in hundreds of thousands or maybe millions of objects just to add an extra one. And that is when your performance will really suffer. One solution in Hibernate is to use a bag implementation, and that will come with Grails 2, but it's not there at the moment. Alternatively, you can use a Lincoln domain class as Spring Security Claw plugin does. So it has a user domain class, a role domain class, and a user role one that links the two. So you don't have collections of roles in the user or collections of users in role. So going back to the fetch mode and indexing, it's very straightforward. Given a domain class user with those properties, to add an index, you have a static mapping block. You give the name of the property, index colon, and then the name of the index. You can use whichever name you want, or it may be dictated by a DBA. So that's just the physical name in the database. On the fetch mode, there are several options described in the user guide. If you have a many-to-one relationship or one-to-one, like user to profile, then it's recommended that if you're always going to access profile information when you have a user, then use the fetch colon join syntax. But if you have a collection, such as user has many roles, then use lazy colon false. Under the hood, that will execute two queries, but that second query will collect all the roles, so once you iterate over the collection of roles, you won't be issuing any more extra queries. So that resolves one of the classic problems called the n+1 select problem. Beyond the physical queries themselves, sometimes you require large volume, and you cannot speed up the queries any longer, or trying to do so means you need a lot of database expertise. So you can go one level above and look at caching. Hibernate has a second level cache, the first level cache being what it calls its session, and that allows you to retrieve domain instances from something like EHCache or some other implementation. I'm going to look at how you configure that in the next slide or two. Alternatively, you can use something of a larger scale, a distributed cache or a data grid such as Terracotta or Gemfire. Alternatively, particularly if you're doing a lot of writes, you may find that the relational database, for example, is not the most appropriate way to store your data, and that you may find that using one of the new NoSQL stores, such as MongoDB, Redis, Cassandra, Neo4j, they may map to your domain model much better and provide better performance. You do have to realize, though, that if you want referential integrity and have a complex domain model like that, the relational database may be your best option. It's something that you really have to look into, find out information online and understand how your model will work. So Hibernate second level cache, in your data source.groovy, you just add this block. In fact, when you create a new Grails application, this will be there by default. So the second level cache and the query cache are enabled by default. So what can this do for us? Well, if you use the get method on a domain instance, that works reliably and well with the cache. That means that if you get a domain instance by its ID, it's highly likely to hit the cache and use that instance. But if you issue a query instead, so a JDBC select under the hood, for example, a dynamic finder or a criteria query or an HQL query, then you'll be looking at the query cache, and then you may find that you're not getting the kind of performance improvement you're expecting. First of all, it's not a simple case of enabling the cache. You have to declare every query that you execute as cached query as well. The user guide has documentation on the syntax for that. It varies depending on whether you're using dynamic finders or criteria query. But you also have to realize that any time data changes in the underlying table, the cache will be cleared. So the query cache only works well for tables in which the data doesn't change very often. For example, a user table is a good example. The user information doesn't typically change very frequently. On the larger scale, you can also implement a data grid. These have a lot of features, so if you want to find out more, I would look at the various websites for the tools, the implementations that are available. But the main problem that they help solve is that relational databases don't scale horizontally very well. So you can't just add another computer with another database node because they don't communicate with each other very effectively. They scale very well vertically, so you can increase the capacity and the speed of the server that's running the database, but that always hits limits. So instead, if you need a high volume, if you're dealing with a high volume of traffic, then you can have one of these data grids, and then when you need, when the volume's getting too high for your current setup, then it's very easy to create new nodes of the particular data grid to handle the information. And data grids are, they can be as simple as a big heap. So you could have instances that are gig or up to 100 gig, and you treat them effectively as memory sitting in front of the database as a big cache. But you can also do more advanced things. You can execute functions within the data grid itself. But for this particular use case, you can use it as a great big heap, and in particular, you can decouple your database from your application so that your application just talks to the data grid, such as Gemfire or Infinispan, executes all its queries against the data grid, and you get the performance almost like in-memory performance. And then, as a back-end process, completely asynchronously, the database keeps itself in sync with the data grid itself. So you've still got persistent data, all the information is still in your database, but you're not suffering from bottlenecks at the database level. Going up to the next level of business logic, you can cache like your service methods. We have a Spring Cache plugin for that, which I'm going to look at again in a little while. It's very simple. It gives you some annotations that you can apply to your service methods, and the caching will happen automatically. Alternatively, a very common solution for long-running tasks is to go asynchronous, and there are many options for Grails applications. You can use something called the Spring Events plugin, which allows you to publish internal events within your application. If you know Spring fairly well, it uses application context event system, but it executes the listeners on separate threads, so it's running asynchronously. You can also just start up new threads using the executor plugin. Both of these are particularly useful because they handle the intricacy of dealing with the Hibernate session in the background. So although you can use thread.start, it's better to use the executor plugin because it will handle all the Hibernate, the GORM stuff in the background without you having to worry about it. And then you can go up a level if you need to offload jobs to external systems. Then you can use messaging, so you have JMS plugin, or you can use AMQP via the RabbitMQ plugin. So various options available. If you find, and I definitely recommend you profile before contemplating this, but if you find that some of the Groovy code itself is a limiting factor, it's a bit of a bottleneck, you can always fall back to Java. Particularly, you can rewrite services in Java. And given that Java and Groovy have similar syntax, it's a bit of work, particularly if you use very idiomatic Groovy, but it's still easier than going from something like Ruby. It's particularly useful if you're doing numerically intensive tasks that you have to execute within the request thread. These days, there's actually another option if you want to give it a try. Groovy++ is basically a jar file that you can put on your class path, and that provides an annotation. And if you use that annotation, the methods will be compiled statically, and you can improve the performance of a single method very easily using this. It's not at version 1 yet, so there is a little bit of risk involved in using it, but if it works for you, then all to the good. It basically looks like this. Given a Groovy service, you can add an @typed annotation to your method like this. If you don't have an argument to the annotation, then that method will be statically compiled, so you'll get Java equivalent speed from that method. Alternatively, you can use something called typepolicy.next, and that will statically compile anything that Groovy++ can resolve at compile time. And then anything else will be resolved as usual via Groovy. So it means that you can speed up some of the typed code within a method, but still enable that method to use something like markup builder to generate XML. So you get the best of both worlds in some ways. Okay, now going on to the network layer and the user interface. One of the first things that it's worth trying to do is reduce the amount of time that's spent processing and creating your views, actually creating the HTML. It's worth bearing in mind at the moment that Grails 2 is seeing significant improvements in the GSP rendering speed. So caching is becoming less of a requirement, but it's still available for complex GSP pages. Again, Spring Cache plugin, I'm going to talk about in a little while. You can use it for service methods, and you can use it for controller actions, whether it be views or whether they render JSON or XML. You can cache HTML responses or JSON or XML. You also want to try to reduce the number of requests, and that's associated with latency of the network, because latency is how long does a very, very small request take to go to the server and come back. If you've got a lot of requests, any latency can quickly add up to a large delay, which your users may notice. So that's why reducing the number of requests is important. There are various recognized solutions to this, particularly when it comes to static resources, your JavaScript files, your CSS files that you're including. You can set an expires HTTP header on your responses of your static resources, and that means that the browser won't even send a request to check whether the resource has changed. It will check locally the time against that expires header. If it's still within the expiry date, it will just use the cached copy of the resource. It doesn't work so well with large files, large images, large JavaScript, because the browser may clear out the cache to keep it to a reasonable size. You can also bundle CSS and JavaScript files together so that you can get one CSS file and one JavaScript, but still on the server side, you can modularize your CSS and JavaScript. You can also use something called image spriting, and that means merging your various images of similar width into a single image file, and yet then using CSS to to display only one image within that sprite. So in the end, you may have 50 images on your web page, but you only have the one download. You should also try to limit the amount of data transferred to the browser, i.e. this is related to the bandwidth issue. So users may have network problems. Not everyone is on a super fast broadband network. So things you can do, you can minify your JavaScript, or you can compress the data. You can compress the HTML that comes back, you can compress the JSON, XML, you can compress the static resources, the JavaScript and the CSS. And there are several plugins available for this. A couple of relatively old ones, Performance UI and Java, which are both work at compile time, and then they will process your static resources and generate the modified versions that you use at runtime. More recently, there is something called the Resources plugin, and I'll be going into that in some depth and showing a demo. So, going back to Spring Cache, this is how it works with views. You have Site Mesh, which is our layout handling tool. It's a library. You have a Site Mesh filter, which forwards on the request to a Spring Cache filter. Then the Spring Cache filter determines whether the GFP has been rendered, and if so, has it been cached. If it has been cached, then use that. Otherwise, render the GFP again and then cache it. Very straightforward logic. And in your application, all you have to do is import the appropriate package and then add a cacheable annotation to your action. So list is the action that we want to cache. We give it the name of the cache to store the data in. And then we can add a cache flush annotation, which will clear the cache every time that action is executed. So in this particular case, list displays a bunch of posts. Every time you add a new post, that obviously means that the cached list is no longer valid. So we need to invalidate my cache. You can go to the plugin pool to find out more information on Spring Cache. There's more. You can do some quite interesting things with it. It will cache based on URL parameters, for example, so that even if you've got different URL parameters, it won't be returning the incorrect data. It will be cached per URL parameter. Interesting issue is many applications have a dynamic aspect to them, particularly if they support users that can log in. How do you deal with that? Because you don't want to cache the detail about currently logged in user, otherwise everybody will appear as if they're logged in as the first user. Not particularly useful. What you can do is have a main GFP, and then you can use the ginclude tag to include the response of another controller action. So we may have one controller action that builds a box showing the login details, and that's the dynamic part. And then we can have another controller action that delivers the main content. Those are included via ginclude, and then the controller action that generates the main content, that can have the cacheable annotation attached. So we're caching part of it, in fact the larger part of the page, but still getting the appropriate dynamic part displaying to the user. So that's all I want to say about Spring Cache, other than that cacheable annotation works on the service methods as well. So looking at the latency and bandwidth issue, To compress the page content, it does depend on which servlet container you're using. So whether you're using Tomcat, Jetty, or some other. Tomcat has a connector setting. You could configure this in its server.xml file. I'm going to show you on the next slide how to do it for the embedded Tomcat when you use Grails Run App or Grails Run War. I'll show you how you can configure page compression for that. For Jetty, you need to add a gzip servlet filter, servlet filter to your web.xml file. So for Tomcat, you create a event script _events.groovy in the scripts directory, and just put this block of code in there. The event is called configure Tomcat. It passes you a Tomcat instance. From that instance, you can get the connector property and set the compression attribute. So in this particular case, I'm setting it to on. You can also set it to a value, which is the minimum size of response at which you want to start compressing, because you may decide that very small responses, they're not worth compressing. The time taken to compress doesn't offset the time taken to send the response back. So that's how you can do it for the embedded Tomcat. And now for the rest of the talk, we're looking at the resources plugin. This solves several problems altogether. The main one really is how to modularize your static content so that you don't have to link to individual files and use the file names from within your GSP pages and maintain all the resources manually in every single page and layout that you're referring to them. And also, it's modularizing the static content means that you can set up dependencies between content. And plugins can hook into it and make life much simpler for you. You just say, I want to include the resources from this plugin, boom, that's it. You don't have to know what the resources are, what the files you need to include are. It also allows you to bundle files of the same type. Remember, that's one of the solutions to reducing the number of requests that you send to the server. There are additional plugins that hook into the core resources plugin that provide extra features. The caching resources plugin handles that expires header that I was talking about, and will set the expires header to a year in advance for any of your configured resources, your JavaScript, CSS files. It also gives static files a unique name, so that that name only ever changes when the content of the associated file changes. And that ensures that although the expires header is a year in advance, if you change something, the user will still get the latest version of the resource because it now has a different name. The zipped resources will allow you to compress static resources. So this is separate to zipping the HTML or JSON or XML responses, which the servlet container is responsible for. This is for the JavaScript and CSS files. So here's a short demo demonstrating the YSlow tool in Firefox and how you go about configuring resources plugin and the zipped and cached resources as well. So here we have the Hubbub application again. I'm going to just look at the home page, log in, and have a look at the timeline. Once that's loaded, at the bottom of the browser there's a YSlow link. This opens up the tool, and in here is a run test button. So when I run that, I get those results I was telling you about the grading system. So as you can see, I get a C for making fewer HTTP requests. It's saying that I've got 9 separate JavaScript files and 3 separate style sheets to download. So that's an extra 12 requests for this page. There's also S for User Content Delivery Network. I'm not going to talk about that, but there are ways to use CDNs and with the resources plugin. You also see that we get an F for add expires header and an F for compressing components with gzip. So at the moment, none of our static resources, none of the JavaScript, none of the CSS have the expires header set. So here we have the a resources module definition. So I'm saying that I've got two modules defined here, one called common, one called navigation. The common are those explicitly used by my application pages, and as you can see, there are several JavaScript files included, a couple of CSS files, and a fav icon. And then also specify this bundle shared, and what that means is that all of these files, all the files of a particular type will be bundled together before they're passed on to the browser. So the browser will only pull in one CSS file and one JavaScript file for those sets of resources. So how do we use these modules once we've defined them? Well, this is the page before the resources. You can see we've got several links for style sheet, shortcut icon, a couple of JavaScript tags for the JavaScript files. We can get rid of all of those and replace them with a single tag, which is use. This has a modules attribute, and this is where we specify which of those modules that we defined we want to include in this page. So this page, this layout, will include all of the resources in common using the appropriate link. So for example, a CSS file will be embedded with a link tag, and JavaScript will be embedded with a script tag. Of course, the resources plugin needs to know where to put these links. That's where the layout resources tag comes in. You always specify two, one in the head and one in the body. There are two things called dispositions supported by resources plugin. Disposition of head, which means that a resource goes into the head block, and a defer disposition. Anything with a defer disposition goes into the second layout resources. And this helps with JavaScript files, which it's often recommended that you defer the inclusion of JavaScript to the end of the body so that the HTML loads first and then the JavaScript files. And that's it for that particular layout. In another layout, going to include the navigation module that we defined. And you can see the navigation module, and I'm defining a CSS file provided by a plugin, the navigation plugin. While that's starting, if the navigation plugin was to support resources, it would define that CSS file with its own resource module. And then we wouldn't have to define it ourselves, we just use the module that it defines. So that makes your life that much easier. Okay, so back to this page. Let's have a look at what has changed. We run wide slow again. Okay, and as you can see, we now get an A for make fewer HTTP requests. So that bundling has helped solve that particular problem, but we're still getting a D for compressed components with gzip, and still getting an F for add expires header. The expires header still isn't there. If we have a look at the network traffic, we can see that the URLs have moved to a static path, except for these two. There's a spinner.gif and a header logo.gif. That's because they are explicit resources, explicit links in our view. So here we go, an image tag. We can have the resources plugin manage this image simply by changing that image tag to an r:image, specifying the URI for the resource. like so. Okay, if I save that, and now go back to YSlow, refresh, and now that was header logo. If we have a look at it, we can now see the URL has changed. It's now being managed by, served by /static/images. Now, if we want to get the compression of our components, compression of JavaScript and CSS files, and get the caching, then we need to install two other plugins. First is cached resources, and the second is zipped resources. There we go. When you install plugins like that, you will have to stop and restart the server. So we'll get that up and running again. And note that we haven't done anything else. We've just installed. We've defined our modules, we've added the R image tag, and we've restarted the server after installing those plugins. And that's it. And now if we log in again and run YSlow on this page, we can see that compressed components with gzip is still an A. We're still getting an F for add expires header, but there's a special reason for this. It's because these are dynamic images that aren't setting the expires header, and so they are contributing to the F grade. But as you can see here, none of the static resources are on that list. They all have the expires header set. And again, if we look at the network traffic, we can see that now our resources have this rather long gobbledygook name. It's a hash, and that's being handled by the cached resources plugin. And if we have a look, okay, just missed that, but if you look at the response, you can see that the expires header is set appropriately. Right, so just to finish off now, another aspect to look at is this whole idea of rich user interfaces, using a lot of JavaScript in the browser and doing a lot more work on the client side. So you're looking at fatter clients in effect, but they're still thin clients because they're running in the browser. And then with such clients, you typically just transfer data to and from the server, and that is much less traffic than HTML plus CSS plus all the other resources. And then you use AJAX, the XML HTTP request, to update parts of the page. And that can really improve the performance of your application, simply because you're reducing the number of requests and the amount of data that you're transferring. Various toolkits are available to do these rich tools, rich user interfaces. GWT, Flex are two of them. You can also use big JavaScript libraries such as YUI or Dojo, which allow you to do all of this in native JavaScript. And then the data transfer could be JSON, XML, or if you're using GWT, it could be GWT RPC. And generating JSON and XML is less work for your Grails application as well, so that aspect is typically faster than using GSPs to generate HTML. So, in summary, if you take away nothing else but the first point, I've done my job, always make sure that you profile before you optimize anything in your application. And do remember, always keep it in the back of your mind, always remind yourself of it. I often find myself trying to optimize before I have enough data. It's something that we seem to naturally do, so you always have to be on guard for that. As you've seen, there are various tools available for profiling, especially Spring Insight and App Info for Grails applications. And Spring Insight will work for Spring MVC as well. And there are several plugins available for improving the performance of your application at the various levels, whether it be caching at the database level, or caching at a higher level with a data grid, or the Spring Cache plugin for service methods and generating views, and so on and so forth. As I said at the beginning, many of these techniques apply to any web application. Also, bear in mind that there's something called the law of diminishing returns, which basically means at a certain point, the effort involved in eking out an extra unit of performance is just, the work involved is just too much. You're not benefiting enough. It's costing you more than the benefit warrants. So be aware of that. You know, only go as far as it makes sense. Definitely go for the big performance improvements that are generally fairly cheap to implement, but otherwise, you know, don't go overboard. And finally, Resources plugin will be part of Grails 2.0. It will still be a plugin, but it will be installed by default for new Grails applications, and it integrates with the resource tag. So you don't have to use the special resource plugin tags. You can just use resource to include a image or a JavaScript file or whatever. Okay, so that's the end of the presentation. Here are the URLs for various resources. That's where you can get hold of Spring Insights from the springsource.com website /developer/tc server, and all of the plugins you can find on grails.org/plugins, which is the Grails plugin portal. So we do have time for some questions. Okay, let's have a look at what questions have come through. Okay, so I have a question here. Is Java Melody suitable for Grails performance metrics? Java Melody is another tool, gives some of the information similar to Spring Insights. It is available as a plugin. I have had a few problems with it, but a Grails application is still basically a Java web application under the hood. So yes, Java Melody is suitable as well. Yes, we have a question here. Do we have an expected time frame for improvements in Grails 2? Yes, we're expecting the first milestone for Grails 2 as opposed to 1.4 at the end of this month. And I think we're looking at, you know, a final release in the middle of September, around that time. But expect to see in the first milestone all of the features that will be in the final version. There's a very interesting question here, is how much overhead does Spring Insight add to your application, and can it be used in production? It does add a little bit. I mean, you will notice that your traffic's a little lower, but it's not particularly significant, and they are working on a version that you can install in production systems, because anyone who's done this knows that some things only crop up in production, and it is very useful to have that available. So as far as I'm aware, that's not there yet, but it is coming. I'm sorry, I don't have a time frame for that. There's another question. Would I consider not using the Resources plugin? To be honest, no, not really. Unless you're using something like the Performance UI plugin and you want to do all the processing at compile time and at war generation time, if you want to do everything up front, then certainly the extensions to the Resources plugin are less useful. But the whole idea of modularizing your CSS files and JavaScript files is such a big win that I just can't imagine not using the Resources plugin for future projects. Particularly as more and more plugins, such as the YUI plugin, the jQuery plugin, are all support Resources plugin already. They define their own modules that you can just include straight away in your application. And that tails into another question, which is how does the resources plugin integrate with the various UI plugins like Rich UI? I don't know whether Rich UI has support for resources plugin at the moment, but YUI does, jQuery does, and the Blueprint CSS as well does. Other things like I think the navigation plugin may support it now. And the integration goes to the extent that they define their own modules. So if you want to use jQuery, rather than using the specific jQuery tags, you just use the R-use, or it is in fact now R-require. R-require modules equals jQuery. So after you've installed that plugin, the jQuery plugin, that's all you need to do. And I think you'll see more and more plugins with that kind of support. Also, you can probably find something like the Grails UI plugin may in the future use resources to defer the embedded JavaScript. So Grails UI plugin uses a lot of embedded script tags inside your HTML. And at the moment, there's no way to get it to put it to the end of the page. But with the resources integration, that is now definitely possible. Hasn't been implemented yet, but it should be possible in the future. And I think the same goes for the Rich UI plugin. I think that is pretty much all the questions. So I'll just finish off. And once again, thank you very much for attending, and hopefully see you again in a future webinar.